Okay, the next is, will keep silence. The next is actuators. Okay, so here actuators is nothing but, the actuator is nothing but it is an output device. Okay, it is a where it is going to convert, the electrical or mechanical energy into a physical quantity. Okay, so actuator is nothing but where it is going to convert your electrical energy into a physical quantity or mechanical energy. Example for your actuator is LED, motor, okay, switch. Sorry, switch will not come, but that is piezo buzzer. Buzzer, okay, and relay. Okay, and here all these are all actuators. Actuator is nothing but that is an output device. Okay, where it is going to convert your electrical energy into physical quantities. Physical quantities nothing but your light or heat. Okay, mechanical energy. All these are all we call that as a actuators. Actuators is nothing but that is the output device. Okay, so all these are all your output device here. Okay, and next is, okay, the example for your actuator, whatever you are using the smart watches. You are using nowadays, there is smart watches is there, no? So in the smart watches, there is an ambient light sensor will be there. Okay, ambient light sensor will be there. So based on the environmental light, it will display the brightness in the watch. Okay, so nothing but that is also actuator. Ambient light sensor, that is the sensor where we are going to use in the smartwatch in order to display the brightness, adjust the brightness in the watch. Okay, so that is the example for your, one more example for your actuator. Ambient light sensor, nothing but that is the sensor where we are going to use inside your smartwatch. Okay, where it will capture your surrounding light, okay, surrounding environmental light. So based on that, it will produce the brightness inside the watch. Okay, so this is the one more example for your actuator. Okay, where it is going to convert your electrical energy into a physical quantities. Physical quantities nothing but what? Brightness. Brightness in the sense where it is going to emit the light. Okay, that is what we are going to call that as an actuators. Okay, so first we are going to discuss about the LED here. LED is nothing but light emitting diode. Okay, this is light emitting diode. The symbol for the LED is this is anode and this is cathode. Okay, here in the LED we have a two terminals. Okay, LED where we have two terminals. Okay, that is anode and cathode. Okay, and the symbol for your LED is this one. Where it is going to represent in the form of diode symbol along with the arrow. Arrow mark is nothing but it is going to emit the light energy. Okay, that is what we are going to call that as a LED, light emitting diode here. Okay, LED is nothing but that is the output device where it is going to convert electrical energy into a light energy. Nothing but light energy is nothing but what it is your physical quantity. Okay, so here this is what about the LED. Okay, the application of your LED is nothing but what? That is display. Your LED TVs, LED boards, whatever you are seeing, the devices, output device, nothing but the display devices. All that is made up of LEDs. Okay, now we are going to concentrate on that LED output device. Okay, so if I see this is my LED component. Okay, so here this is my LED component. Okay, the LED component is having the 8 segments, sorry, 7 segments. This is A, B, C, D, E, F, and G. And this is we have a dot. Okay, each actually the whatever the line we call that as a segment here. Okay, the segment is nothing but here. I am going to start. Okay, we are going to start with from here. This is A, B, C, D, E, F, G, and the dot is H here. Okay, we are going to start because this each segment is consists of LED component. If I take this as my A segment, it is made up of the LED component. If I take B segment, it is made up of again the LED component here. Okay, so if I take this is my LED, the purpose of the LED is nothing but in order to display the alphanumeric component. It display the alphanumeric character. The purpose of the LED is nothing but in order to display your alphanumeric characters. Okay, alphanumeric character. In order to display your alphanumeric is nothing but I am going to display the alphabets. The numeric is nothing but I am going to display numerals 0 to 9, and alpha I am going to display A, B, C, D, E, F like that. That is what I am going to use this LED. The LED is nothing but this is the LED display where I am going to use for in order to display the alphanumeric. Alpha is nothing but alphabets, numeric is nothing but I am going to display from the numerals from 0 to 9 here. Okay, and here the each segment, nothing but if this is my LED component, it is a composed of segments. Okay, it is a composed of segments is nothing but A, B, C, D, E, F, and each segment it is a made up of the LED device. A is also made up of LED device. B segment is also made up of LED device. C is also made up of LED device in order to display the light. So each segment it is manufactured or it is made up of the LED device. Whatever you see, that LED it is going to fabricate it inside the segment so that it is going to emit the light here. Okay, so this is what about the LED component here. Okay, and here we have two types of LEDs. We have two types of LED. One is called common anode and common cathode. We have two types of LEDs. Okay, two types of LEDs nothing but where we have common anode and common cathode. What does it mean here? As we know that The LED is having the two terminals, anode and cathode here. Okay, the LED is made up of two terminals, nothing but anode and cathode. So, because if you see, this is my LED segment, LED device. LED device is nothing but what? It is an actuator here. Okay, so as I told, each segment is made up of LED component. A is also made up of LED component, B is also made up of LED component, like that. Okay, so here, if I, as I told, there is a two type of LEDs, nothing but the all the common connection, nothing but let me take the circuit diagram for this. This is my A segment, B segment, C up to H segment. Okay, as I told, this is what? This is my anode and this is my cathode. Okay, so if I connect all the anode terminal to the 5 volts. Okay, so in the common anode is nothing but what? Because in the LED component, how many segments? We have 8 segments. A to G is 7 plus 8 is 8. Okay, so all this segment is having the two terminals, anode and cathode terminals. All the segment it is having the two terminals, anode and cathode terminals. If I connect all the segment of the LED device, that is A segment, B segment, up to H segment is having the anode segment here. Okay, if I connect all the anode segment to the common connection, that is if I connect to the positive supply, that is we call that as a common anode LED. Okay, common cathode is nothing but the same thing. Have this LEDs. This is my A segment, B segment, C, and this is my H segment. All this cathode, all the cathode I am going to connect to the ground connection. Okay, so all the cathode I am going if I all the cathode segment of the LED is connected to the ground connection. Nothing but why you call that as a common cathode? Because I am connecting all the cathode terminals. I am connecting all the cathode terminals to the ground. That is what we call that as a common cathode. But in the common anode, all the anode terminals of the segments, all the anode terminals of the segment, I am connected to the plus 5 volts, that is power supply connected. Because as the anode I have connected as a common connection. All the anode terminals is having the common connection and which is connected to the plus 5 volts. We call this as a common anode. And all the cathode segment it is connected to the ground connection, we call that as a common cathode connection. Okay, so this is the two types of your LED. And if I take LED device, the LED device it is composed of the LED component or integrated the LED inside the device. That is nothing but that is your output device here. Is it clear? What is the purpose of LED? Why we are using? In order to display alphanumeric characters. Okay, and it is a output device. Output device is nothing but what? It is also a transducer. Okay, it is also a transducer because it is going to convert from one energy into the another form of energy. Okay, actuator is nothing but it is output device where it is going to convert one type of energy into another form of energy. That is what we call this as a transducer. Okay, and again we have two types, that is common anode and common cathode here. Okay, is it clear? You want to copy this? Maybe notes I will share today or tomorrow, within tomorrow. Okay, regarding this third module. Did you copy this? And actually we call this as H is nothing but we call this as a decimal point. It is nothing but decimal point. We call that H segment is a decimal point here. Okay. And next here, if I connect, as I told, okay, so let me take, this is my, this 8051 is nothing but your microcontroller here, and we have a port pin number 2.1, 2.2 up to 2.7, and this is 2.0. Okay, port is nothing but that is the pin of your microcontroller. Pins. Ports is nothing but pins of your microcontroller in order to interface your devices. Okay, so if I take, so how I am going to interface my LED to the, this is my LED device. Okay, as I told, this is pins of your LED. Okay, A segment, B segment, D, E, F, and G, H here. All the segment of the LED, if I want to interface, here I am going to explain how we are going to make interface of your LED with your microcontroller. 8051 is nothing but your microcontroller. Okay, in the microcontroller we have a ports. Ports is nothing but in order to make the connection between, it may be input device or it may be output device. Okay, actually we have 4 ports, port 0, port 1, port 2 and port 3 in the microcontroller. We have 4 ports, but it is not now. We are going to discuss about the ports. I gave the information how many ports we have in the 8051. We have 4 ports, port 0, port 1, port 2, port 3. All the ports it is having the 8 pins. Okay, and if I want to make interface of my LED device to the microcontroller means in the LED I have the segments, that is nothing but A, B, C, D, E, F, G, H. Okay, and these are the pins of your LED device. These are the pins of your LED device. If I want to make interface, just if I connect the port 2.0 to A pin of your segment, port 2.1 to, sorry, port 2.1 to B segment, port 2.2 to C segment. So like that, if I make connection, that is nothing but the interface connection. We call this as a connection, nothing but we call that this as interfacing. Interfacing is nothing but I am going to connect my input or output device to my microcontroller here. Okay, so that is what we call this as an interfacing. Here just I am giving you the example how we are going to make the interface between your LED device as well as your the microcontroller here. Okay, as I told, the LED is nothing but it is a 8 segments, is nothing but each segment is A, B, C, D, E, F, nothing but these are the pins of your LED device. Just if I connect to this LED pins to port number of a microcontroller, we call this concept is nothing but interfacing. Call this as concept is called interfacing. Interfacing is nothing but connection of the port of your microcontroller to the pins of your LED device. Okay, this we call that as interfacing. But along, if I want to connect the sensor, that is also interfacing. Sensor is nothing but what? It may be input sensor, output sensor. If I connect that is also to the microcontroller, that is also we call that as interfacing. Okay, and this is what about the connection of your LED device to microcontroller. Okay, and here the next is, here I want to display, I want to read the values in terms of hexa characters. Okay, so as I told, here I want to, the purpose of LED is nothing but what? I have to display the alphanumeric character. Okay, here this is nothing but the 8 segment. Okay, and this is my A, B, C, D, E, F, and G, and H here. I'm not considering H. Just a moment. Okay, so I want to see, this is, if I want to display the character called 0. If I want to display the character called 0 in the LED segment, what I have to do? I have to blink all the segments A, B, C, D, E, F except. Is it or not? Because in the LED we have either 8 segments. Is it or not? We have 8 segments. But if I want to display the character called 0, okay, what I have to do? I have to blink A, B, C, D, E, F except G. Nothing but what it will display the character called 0. So how can I write the values for this in the hexa value? So let me take this is A, B, C, D, E, F, and this is G, H here. Okay, so here I am taking as a common anode. First, you have to check whether it is a common anode or common cathode. Okay, I am connecting. This is the common anode. Common anode is nothing but what? I am connecting all the anode terminals of my LED device to the power supply here. Okay, if I want to blink, what I have to do? I have to make this as a ground connection. Potential difference I have to create. Potential difference is nothing but what? I have to make this as a 0 volts. The cathode terminal of my device, I have to make it as a 0 volts. Then only it is going to blink here. Okay, so if I want to blink, what is the value I have to assign to the A segment? 0. See, I connected because I already given the plus 5 volts to all the anode terminals. Okay, I already connected all the anode terminals of 5 volts. You have said here it is correct, that is one only. But along with that, I have to make the potential difference of 1 volts. That is 1 is nothing but 5 volts. I have to make cathode terminal to the 0 volts. Nothing but what I have to make? That is 0. I have to make this as a 0. This is 0. This is also 0 because I am already giving the potential here. 5 volts I am giving here. Okay, common anode give 0 means again this is a 0 connection. Again this is 0, 0, 0. But G is 1 and G is 1. Take or not take, H is not, but I am taking H as a 1. Okay, is it clear this concept? See, let me explain. I am connecting all the anode of my LED to the plus 5 volts. Okay, I am connecting all the anode terminals of the common anode is plus 5 volts here. Okay, I have to make the potential of 5 volts. I have to make the potential of 5 volts is nothing but what? I have to connect the cathode terminal to the ground connection. I have to make the cathode terminal to the ground connection. Nothing but I have to supply 0 volts to the cathode terminal of my LED device. So nothing but A segment is 0, B segment is 0, C, D, E, F. Nothing but it is going to display my 0 character on the LED device, except G and H. So if I group of 4 bits, if I group of 4 bits, nothing but I am going to convert this binary into hexa values. I am going to convert this binary into hexa value. What is the binary hexa? This is 4 zeros. If you go into the relationship table between binary and hexa, the combination of 4 0 bit that is equivalent to 0, and this is 0 0 1 1. Nothing but 3. If you open your book, that is relationship between binary and hexa table, the 4 bits of 0 0 1 1 that is equivalent to hexa value. Nothing but if I give 0 3, nothing but this is the hexa value. This is the hexa value. Okay, this is the hexa value in order to display the 0 character on the LED device. Is it clear? I think someone will not get it. Is it? Okay, let me explain one more example. Okay, see here I have, see, this is the 8 segment. Okay, in the 8 segment, I want to display the character called 1. blink B segment and C segment. I have to blink. See, this is my LED device. In that, I have to blink the character called 1. I have to blink the character called 1, and all the segment I have to make it as a 0. So what you do? Here, except B and C. Except B and C, make it as a 0, 0. And remaining to make it as a 1, 1, 1, 1, 12. See? See, which segment I have to blow for one character? B and C segment. Is it or not? Or you can blink F and D also. There is no issue. See, I want to display the one character on my LED display. Which segment I have to blow? B and C means you have to make B and C as a 0, 0. Okay, and all other you make it as a 1, 1. And again, it remains group of these 4 bits. What is the equivalent of this 1, 1, 1 in the hexa? This is F, and this is 9. Nothing but see, this is the hexa value. This is the hexa value in order to display the one character on the LED segment. Is it clear? This is the hexa value. Just I am telling how we are going to convert this back into hexa value. That's all. Okay. For example, let me take that 2. I want to display the character called 2. Okay. This is A have to be B, G, and E. I have to be. Okay, which one I have to make? You make that as a 0. A means I have to make it as a 0. B means 0 for 2 character. Okay, 2 character have to make. 2 means we also have to make. Next is G, C, D, E. Nothing but again, D is nothing but what value I have to assign D. G. Next. Then next, which one? G is 0 and remain as a 1, 1. Is it clear? Is it clear or not? So now you look as a 4 bits. 2 by 4 bits. Nothing but what this is? This is 2 and this is 5. Sorry. Nothing but if I want to display the 2 characters on the LED device, the hexa value is 2, 5. Is it clear or not? Clear or not? Any confusion? Will you tell me the exam? You tell me for the characters of 6. You tell me what is the hexa value for this 6 characters? Hexa value. You tell me what is the hexa value for 6. Write down the values because whatever the characters you want to bring, you make that as a 0, 0. Huh? 4, 1 H. See here. First part I have to display the 6 characters. What you have to make? You have to bring A, F, and next is E, D, G, C. You have to bring this. Are you getting my concept? I want to display the 6 characters on the LED means I have to bring all the segments. Okay, for that one, A I have to make it as a 0. Next is what? Next is what? Which one I have to make it as a 0? C. Then E for what value? Then next. Okay. And for me, then what you do? Is it clear? Clear or not? Any doubt in this? Try for 8. 8. Try for 8. What is the value, extra value for your 8? Huh? 0? 0. What is the hexa value for your 8 character? Anybody come and do that? Did you get this concept? Huh? Did you get it or not? Whose pen it is? Okay, did you understand now? Any doubt in this? Okay, the next is the stepper motor. The next is the stepper motor. Okay, stepper motor is nothing but where it is going to convert silence. Stepper motor is nothing but where it is going to convert the electrical energy to the mechanical energy. Motor is also called that as a actuators. Okay, motor is also called that as a actuators. And if you come into this, silence, silence. So here motor is nothing but I am going to discuss the stepper motor here. Okay, we have two types. One is called unipolar, other one is called bipolar. There are two types of the stepper motor. Okay, see the difference between the DC motor and the stepper motor. The DC motor is nothing but it is continuously run. Okay, the DC motor is nothing but the DC motor is silence. The DC motor is nothing but it will run continuously. But the stepper motor it will run in the discrete manner. It will run in the discrete manner. Nothing but discrete manner is nothing but what? If I am going to if I give that time in order to run for 10 seconds, okay, it will run for 1 second, 0 to 1 it will run, again for 1 to 2 it will switch off, again 2 to 3 it will run, and 4 to 5 is switched off. Nothing but in order to run in a discrete manner, that is what we call that as a stepper motor. This okay, stepper motor is nothing but it will not run continuously. It will run at a specific instant of time by applying the voltage to the input terminals. Okay, if I for example I told if I want to run my stepper motor discrete manner in a sense, for example 0 to 10 seconds I want to run. Discrete manner means I am going to apply 0 to 1. It will run on, and 1 to 2 it will off, and 2 to 3 again it will on. Nothing but we call this as a discrete manner. It will not run at continuously motion. Are you getting? What is the difference between continuous motion and discrete motion? Discrete motion is nothing but it will run bit by bit. Okay, that is what we call that as discrete manner. Okay, so this is the difference between a stepper motor and the DC motor. And application of the stepper motor is nothing but we are going to use in the robotics, dot matrix printers, disk drive, dot matrix printer, robotics. All these are all the application of your stepper motor. Okay, all these are the application of your stepper motor. Is it clear? The stepper motor is nothing but that is an electromechanical device. Electromechanical in the sense what? It is going to convert your electrical energy to the mechanical energy. This is also we call that as a actuators. Sorry, actuators. This is also we call that as a actuators. Nothing but transducers. Transducers is nothing but what it is going to convert one form of energy into the another form. Okay, so this is also we call that as a actuators or transducers. Okay, application of your motor is robotics, dot-matrix printers, disk drive. These are all the applications of a stepper motor. And the compare between the DC motor and stepper motor is the DC motor it will run continuously, but in the stepper motor it will run in a discrete manner. Okay, so this is the about your the stepper motor and the category. We have two types of, one is called unipolar, other one is called bipolar. Okay, that I will discuss in the next class. Okay, unipolar and bipolar.